Okay, so let's get started. Good morning to all of you. This is the second lecture on large language models, and today we will try to introduce NLP within an hour, which is impossible, right? So what I will do, I will try to try to give you a very high level overview of NLP. But as I mentioned earlier, you are strongly recommended to go through any NLP course, right? If you have taken my NLP course last semester, then you are okay. Otherwise, please go through an online NLP course. Okay. So breaking news. So yesterday Llama 3.1 was released. Okay. So Llama 3 was released in April 2024, and yesterday the updated version of Llama was released by Meta. And I don't know, but over the entire course how many new models will be released, right? That is something that we will look at, we'll also follow, and I will also give you an update on the new models. Okay, so Llama 3.1, it basically came with three versions: 8 billion, 70 billion, and 405 billion models. This is the largest Llama model ever introduced. And if you want to know more about it, this is the website where they released the model along with the version and other details. This is an open source model. As we all know, Llama is an open source model, and this 400 billion parameter models, some of the important aspects are as follows. The model was trained on around 15 trillion tokens, right, using a context window of 8k tokens, right? And this at least the largest model of Llama 3.1 has already shown quite significant performance on different benchmark tasks. Specifically, it already beat the baselines like Claude 3.5 Sonnet and GPT 4o, the recent version of GPT. Okay, so this is an open source version. You can download, you can use it, but if you have memory of 820 GB, right? So if you think that your laptop has 820 GB memory to load this, you are welcome to load. A new, this is called a new type of open sourcing, right? You open source it, but you know that it would be very difficult to download. And of course, this, look at the training resources, right? So the model was trained on 16k 800 GPUs, right? IIT Delhi doesn't have any 800 GPU, by the way. 16k 800 GPUs were used to train this model. Okay, but of course, if you don't have space, memory, etc., you can use the 8 billion model. Maybe this is better than Llama 3. Okay, so I will start off by showing this example. Okay, this is a recent example news articles taken from Times of India on the assassination attempt on Donald Trump, and this is the headline, right? Donald Trump's death. Okay, so you may wonder, possibly there are some mistakes in this title. There are punctuation errors and so on and so forth. We'll figure out later, but remember this and think whether the title is correct or not. Okay, but yeah, so let's go, let's proceed. What is NLP? So NLP is natural language processing. We all know what is a language. Language is a medium of communication. Natural language is essentially a language which has evolved without maintaining any grammar, right? So it has evolved automatically, naturally, right? And then the grammar has been introduced. Okay, so it is not like the artificial language, right? Like, let's say Python or C++, other types of programming languages, where first the grammar was introduced and then the language was introduced. Okay, so, and natural language processing is a field of computer science, AI, and computational linguistics, which basically concerned with interactions between computers and human languages, right? So I mean, this is of course controversial, but generally we use this Venn diagram to identify the position of NLP within this space. We have CS, human language, and AI, and at the intersection of these three space, we have this NLP. Okay, so why NLP is interesting? Because of the diversity. Language has a lot of diversity. I mean, if you look at world's language, there are more than 6,000 languages across world. These are official languages, by the way, right? So if you also consider dialects, nobody knows how many dialects are there in the world. But if you look at India, there are 19,000 languages, right? It's difficult to digest, but this is an official report. It includes the official languages as well as dialects, right? I mean, I'm a Bengali, so I can tell you the amount of dialects that are there in West Bengal and in Bangladesh, right? If you go to West Bengal and Bangladesh, you will see crazy amount of variations, right? There are people from Bangladesh, they can tell you, right? If you go from east to west of Bangladesh, you see a huge variation. In fact, the western part of Bangladesh may not be able to understand the eastern part of Bengali, right? So lots of dialects, and that essentially makes the entire business so difficult to process. Okay, so like computer science, NLP. I mean, if you're asked who is the father of NLP, of course, one and only Turing, right? And we all know about Turing test. This is the famous paper, computing machineries and intelligence, right? So in the Turing test, I hope all of you know what is Turing test, right? So in Turing test, you essentially, let's say you have a room, the room is partitioned, and in one partition, you have this is human being, on another partition you have a computer and human being. So if there is a sound from this partition coming in, right? So the human being should, the task of the human being is should basically to identify whether the sound is essentially generated by the machine or the human being, right? So if C is successful, then A, the machine, actually fails the Turing test. If C is not successful, then A essentially passes the Turing test. Okay. But of course, when we talk about modern linguistics, computational linguistics, Noam Chomsky is considered as the father of modern linguistics, right? We all know the universal grammar proposed by Noam Chomsky, right? We all know Chomsky's normal form, right? We'll also talk about it maybe later if time permits, but he's a living legend. Some of you know that just few weeks back there was a rumor about Chomsky's death on Twitter, right? And then after 2-3 hours of that rumor started spreading, it was debunked. Why is NLP challenging? Some of you who have taken my course last semester, these slides might be a bit redundant, but this is important just to make the course complete. This is challenging because of the ambiguity, right? Let's look at this example again. How many of you think that there's an error here? It should have been Donald Trump's death or whatever, I don't know. Apostrophe is missing? What do you think? What other things? Is this correct?
T should be lowercase.
T should be lowercase. Why?
This is factually wrong.
Factually wrong. Okay. Yeah. So the Trump here is used as a verb. Trump card. Okay. So basically Donald Trump's death. Okay. This was a very interesting example floated on Twitter, and my TA actually spotted this. So I thought this is a nice example to start with. Okay, and that's why NLP is really crazy. There's another example, right? So if you look at this sentence, Virat Kohli was on fire last night. He totally destroyed the other team. It doesn't mean that Virat Kohli was standing on fire, right? So, and we all know the meaning of this, right? So the literal meaning, the surface meaning of a sentence may not be same as the actual meaning of the sentence, right? And that is something where we need linguistics as well as computing, right, to essentially teach the model to learn world's knowledge, to learn pragmatics, to learn discourse, and so on and so forth. Okay, but it is not about language where ambiguity is present, right? If you look at this picture, right, so somebody can say that this is a picture of a rabbit, somebody can say that this is a picture of a duck, right? So ambiguity is everywhere. But we'll talk about ambiguity in language, right? Let's look at this sentence here, right? Of course, you can say that these are very simple examples. I mean, human being can easily process these examples, but it's not as simple for a machine to process it, right? So look at this one. I saw a girl with a telescope, right? So who had the telescope? The girl had the telescope or I had the telescope? It's not very clear, right? So, but if I, but of course, if you maybe if you think of it carefully, it seems that I had the telescope, right? But it is also possible that the girl had a telescope and I saw the girl. If you use the same syntax, the syntax that is present in this, okay, the syntax is basically grammar. Okay, if you use the same syntax to write these two sentences, I saw a girl with a bicycle, right? Or I saw a bus with a telescope, things are very clear, right? There is no ambiguity because I can't see a girl through a bicycle, right? So it is obvious that the girl had the bicycle. Similarly, I can't. Similarly, the bus did not have a telescope. Of course, bus is not a human being, so it is very clear that I saw the bus through telescope. Okay, so the same syntax, but the first case, the first sentence was a bit ambiguous. If you do not know the semantics, I mean, it's very difficult to decipher the semantics. Whereas the next two sentences, the semantics is very clear. Okay, so the next example is this one. Mary had a little lamb. Okay, so what do you think? Is this ambiguous?
Yes.
This is also ambiguous because in one case it is indicating that Mary had a lamb, which was basically an animal, right? Whereas the other example, the other semantics can be that Mary basically ate a lamb. Okay, let's look at some of the regional languages. Hindi, for example, मुझे आपको मिठाई खिलानी पड़ेगी, right? So it is not very clear who is offering mithai to whom. What do you think? Who is offering mithai to whom? मुझे आपको एक मिठाई खिलानी पड़ेगी, मुझे आपको एक मिठाई खिलानी पड़ेगी, right? So it depends on, so this is called pragmatics. Okay, it's a very interesting aspect of NLP, right? It has been very interesting aspect of NLP before LLM hijacked the entire world of NLP, right? But pragmatics deals with the way you speak, right? The tone, the intonation, the hand movement, the face movement, and so on and so forth. Based on that, you determine the meaning of this sentence, right? For example, let's say if somebody, if let's say if I ask this boy, right, who is coming to the class now, what's the time? Exactly. So if I ask him what's the time, so he is basically giving excuse that sorry sir, I was not able to find the room, etc., right? But the ideal response would be the time is 11:05. Okay, please come and sit. Okay, so this is important. Now let's look at this three sentences now. I ate rice with spoon, I ate rice with curd, I ate rice with Rahul, right? Same syntax, right? Syntactically they are same, but semantically they are very different. Okay, spoon was used here as an instrument, right? Curd was used as an auxiliary food, right, with rice, and Rahul here basically was used as somebody who was accompanying me, right? So they are very different. Now let's look at punctuation ambiguity. Okay, so if you look at this sentence, let's eat grandma, right, versus let's eat comma grandma. If you look at the sentences again, The only difference is in terms of this comma, right? But the meaning is completely different. So punctuation is very important. I'll show you some other examples, some other crazy examples. Look at this one. A woman without her man is nothing. Okay, so we all understand the meaning of this, right? Now let's look at the beauty of punctuation. A woman without her man is nothing. This is the meaning that we can interpret easily. Now if you add this colon here and a comma here, a woman colon without her man is nothing, right? So this is the power of punctuation. Now let's look at this one. This is my favorite example, right? I always start my NLP course with this example. Okay, so buffalo, 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 buffalo. 8 times the word buffalo is repeated, right? Do you think it's a valid sentence? Right? This is a valid sentence, and this is one of the crazy sentences that people always use to basically show that how NLP is difficult. So if you look at this sentence, the word buffalo, right, has 3 meanings. Buffalo is used as an animal, buffalo is used as an American state, and buffalo is used as a verb, right, which means to bully someone. Clear? 3 meanings. Now look at it carefully. Now look at these color codes. Now look at this carefully. Now I just added a few punctuations here and there. Now look at it. Buffalo, buffalo, meaning the American state's buffalo, right? Who other buffalo, 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 right? Right? Meaning, so there are 2 sets of buffaloes here in American state, right? So one set of buffaloes are bullied by another set of buffaloes, right? And they also bully them. So buffalo, buffalo, whom other buffalo, 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 buffalo. Okay, so this is a valid sentence. Now why NLP is difficult? NLP is difficult because of specifically these issues, right? So we have non-standard English, right? And specifically in the era of social media, we see a lot of non-standard English like LOL, right? Retweet is also a not a grammatically incorrect word, but it's not a dictionary word. Okay, so non-standard English, then segmentation issue. If you feel that a space can be used to segment tokens, right, that may not be correct. For example, if you look at here, the New Haven Railway, right? If you tokenize it using space, you will get a separate, a very different and erroneous tokens essentially. The third problem is idioms, multi-word. Okay, so multi-word is a term that we use in NLP to indicate those terms which are whose surface meaning is very different from the actual meaning. For example, hot dog. Okay, surface meaning is a dog which is hot or who is hot, whatever, right? But the actual meaning is basically a food. Similarly, all the phrasal verbs, right? Regional languages, if you look at phrase like khana, khana bana, khana pina, etc., right? And so on and so forth. Neologism. So it's basically those words which are not a part of dictionary. For example, unfriend, retweet, right, and so on and so forth. LOL. Words knowledge. Words knowledge is very important. For example, I think in 2014, 2015, there was an article which essentially showed that one of the parsers, right, one of the parsers which was built based on Stanford's corpus, it was not able to recognize Michelle Obama as the wife of Barack Obama, right? It essentially returned Michelle Obama as the wife of George Bush. Okay, so words knowledge is very important, and it's very difficult to incorporate words knowledge into the model. And the next the tricky problem is the tricky named entity, right? Let's say let it be was recorded. You need to understand that let it be is a single named entity. right? And it is referring to a song, right? But if these three words let it be appear in a different context, right, and then you consider let it be as three different tokens, right? But if it appears in the context like this, then you have to identify, or you have to mark let it be as a unique or single token. Okay. Okay, so in NLP, when you talk about NLP is categorized into two components, or two aspects are there in NLP. One is natural language understanding, right, where we mostly try to understand a language, right, meaning let's say sentiment analysis, right, part of speech tagging, parsing, and so on and so forth, right. Whereas the other aspect is natural language generation, right, where we talk about generating a language, generating a sentence, generating a phrase, right. Chatbot basically comes under natural language generation, where we generate sentences, tokens, and this is the layer, NLP layer, that we follow generally. We start with morphology. Morphology deals with, I'll talk about all these layers one by one, but in a very high level overview, morphology is basically study of word structure, right, prefix, suffix, infix, circumfix, and so on and so forth. Then we talk about syntax. Now within syntax, we have POS tagging, part of speech tagging. We all know what is part of speech tagging, right? There is chunking. In chunking, we essentially group different words into chunks, right? Noun chunk, verb chunk, and so on. And then we have parsing. The parsing deals with the actual syntactic understanding of a sentence. We try to build a parse tree, right? A grammar essentially, right? From the sentence. Then the most difficult part is semantics, right? So morphology and syntax, these two things essentially deal with the surface form of the sentence, surface form of the token, right? But when it comes to semantics, and the upper part of semantics, pragmatics, discourse, these layers essentially connect NLP to the world, to the society, right? Because now we start thinking of pragmatics, context, world knowledge, and so on. So semantics deals with understanding the meaning of it, and then the last one is pragmatics and discourse. Okay, so pragmatics is essentially about pragmatics is all about context, right? Depending on the context, the meaning of the sentence can change, and discourse is basically about a discussion, right? Let's say there's a discussion happening between two parties, multi parties, right? We look at the entire context and then we respond accordingly. Okay, so from bottom to top, we basically move towards increasing complexity, and the model will also become harder and harder. Now this is called NLP Trinity. Okay, so you see a three-dimensional figure here, right? X-axis indicates different languages, right? We have Hindi, Marathi, English, French, etc. Y-axis indicates different tasks, right? Parsing, POS tagging, morphology, right? Semantic role leveling, and so on. So this is task, this is language, and this is algorithm. Okay, so CRF, HMM, hidden Markov model, conditional random field, MEMM, right? Maximum entropy Markov model. But there are other models, deep neural network, LLMs, etc. Right? So these are essentially models to solve these problems across these languages. Okay. Okay, now let's look at these layers one by one. I'll again very briefly talk about it. I'll not talk about any algorithm to essentially solve these problems. But if you, let's say, if you go through Zurawski-Martin's book, you can easily understand it. But if also you can take any online lectures if needed. So the first and most important part is the word or a token, right? As I mentioned last class, I guess, token can be a word, token can be a character, token can be a subword, right? And specifically in the context of LLM, tokenization is very important, right? We will talk about different types of tokenizations later on. byte pair, word piece, sentence piece, and so on and so forth. But tokenization is very important. Don't assume that tokenization can be possible by using this space. You use this space and then you tokenize words. It's not that easy. Okay. For example, if you look at the first sentence here, you may use the you may use punctuation like comma, full stop, and space, right, for tokenization. But if you use the same way to tokenize this sentence, right, it will produce an erroneous token, because you see here this entire sentence is a single token. This entire number is a single token, right? So this is important. Now, if you feel that, let's look at, if you consider full stop as a delimiter, for example, for tokenization, you fail here, right? Because this URL is a single token, right? You can't split the URL into multiple tokens based on this full stop, right? And similarly, these days hashtags are very popular. So hashtag, within a single hashtag there is no space at all, right? So great day ever, if you want to tokenize it, it would be very tough to tokenize. Okay, so morphology, as I told earlier, morphology is basically a study of words, how they are formed, their relationship to other words in the same language. It also analyzes the structure of the word, parts of the word, suffix, stem, root words, prefix, and so on, right? So if you have a morphological parser, right, if you feed, let's say, if you feed independently as an input to the parser, the parser will essentially return this independent plus ly. Independent can also be broken into independent ly, right? So essentially you will see that parser may return this one, independently, right? So these are individual morphemes which are used to essentially form this particular token, right? How do you do this kind of tokenization? There are ways like, we can use finite state automata, right? If you are aware of automata theory, right, use finite state automata to essentially, and you have multiple rules, and you use those rules for splitting a word into multiple morphemes. Okay. Now here in this context, another aspect is very important. So essentially what morphology does, morphology returns the stem of a word, the root word of a word, root word of a surface word, right? And it separates the other affixes, right, like infix, prefix, postfix, and so on, right? So in this context, we need to understand the difference between stemming and lemmatization. Okay, so stemming and lemmatization, these are two types of algorithms used for morphological analysis, right? Stemming returns a stemmed word or a root word which may not be a dictionary word, whereas lemmatization returns a root word which will always be a dictionary word, right? Then the obvious question would be, why do we need stemming? Lemmatization can be useful. We can only use lemmatization. Why do we need stemming? The reason is that the reason behind using stemming is that stemming is very fast, right? Stemming is compared to lemmatization, because in order to do lemmatization you need to have a dictionary, right? And dictionary is something which always changes over time, right? So but stemming at least guarantees, most cases guarantees, that if there are two different surface words, if they are generated from the same lemma, right, stemming always guarantees that their stemmed word is always the same. So you can always say that you can always identify whether two surface words essentially came from the same root or not. Okay, so morphology, if you look at different languages, English, Chinese, etc., right, they are morphologically poor languages, right, whereas languages like Hindi is morphologically rich. Now let's look at example. So I will go, we will go, you will go, he will go, she will go, right, same kind of same surface sentences, right. Now if you look at the Hindi translation of these sentences, मैं जाऊंगा, वो जाएंगे, right, तुम जाओगी, वो जाएगा, वो जाएगी, and so on and so forth, right. So the complexity in Hindi language is that the verb itself is what? The verb has a gender, right? So in fact, I have not been able to understand this properly, but therefore, right, languages like Hindi, Hungarian, they are morphologically rich language. Okay. Syntax. So syntax concerns the way in which words can be combined together to form a sentence. Okay. Right. So POS tagging, chunking, parsing, these three steps basically are part of the syntactic analysis of a language, right? POS tagging. Part of speech tagging we all know, right? How many part of speech you are aware of? Noun, pronoun, adjective, verb, adverb, preposition, conjunction, interjection, article maybe, right? But in English, there are different types of tag sets, right? For example, if you follow Penn-Trebank nomenclature, Penn-Trebank tag set, there are 45 English tags. Tags like PRP, personal pronoun, VRD, verb past, right? DT, determiner, there are 45 such tags, right? If you look at C7 tag set, there are 146 tags. So it's not as simple as we think of, okay? But here also in POS tagging, there's a problem of ambiguity, okay? Let's look at these two sentences. He went to the park in a car. They went to park the car in the set. So the word park here is used in the first sentence as a noun, in the second sentence as a verb, right? So if you think that if we can just create a dictionary, right, or list where all possible words and the corresponding POS tags, can be added, and when we talk about POS, we just look at the dictionary and then fetch the relevant POS tag. That's not going to work. Okay, you need to understand the context again. Chunking is the second step within syntax, right? So chunking deals with essentially segregating different tokens into groups. For example, here the word he is a noun phrase, right? Went is a verb phrase. To is a prepositional phrase, and the Indian city Mumbai is a noun phrase, right? Now let's look at this one. This is not that easy, by the way. Let's look at this one. Mumbai green lights, women icons on traffic signals, earns global praise, right? So here, Mumbai green signal, women icons. This is a single noun phrase. Okay, on is a prepositional phrase. Traffic signal is another phrase, another noun phrase, and then earns is a main verb. Okay, and then praise, global praise is essentially a noun phrase. Okay, so now once we are done with POS tagging and chunking, the next stage is parsing, right? And what is the purpose of a parsing? The purpose of a parsing is essentially, given a sentence like this, he eats a mango, right? Your task would be to build this kind of tree. Okay, let's assume that you already know the parts of speech of all the tokens. Let's say he is PRP, right? Eats is VBZ, right? A is determiner, mango is NN, right? And then your task would be to group this first level POS tags, right, into chunks, right? DT, so determiner and noun, they are combined to basically form the noun phrase, right? Then verb phrase and verb and noun phrase are combined to form the verb phrase, and so on and so forth. Okay, now this is not simple. Let's look at this. Let's look at an ambiguous example here. The same example. I saw a girl with a telescope. Okay, so if you look at the first level POS tagging, right here, oh sorry, like this. Okay, the first level POS tagging is the same, both the cases, right? But in this case, where I had the telescope, right, and via the telescope I saw the girl. Here, here what happened is that this noun phrase, right, and the preposition, they are combined together to form this PP, prepositional phrase, and PP, NP, and verb. So verb, noun phrase, and prepositional phrase, they are combined together to form the verb phrase, right? Whereas here you see that say this PP, NN, and determiner, they are combined together to form a noun phrase, right? So then the noun phrase and the verb, they are attached and they form the verb phrase, right? So in this way we basically resolve the ambiguity problem. Now the next step is semantics, and semantics, as I mentioned earlier, semantics is a step after which from semantics and after semantics we essentially try to connect language with the world. Okay, so semantics is concerned with meanings of words and how they are combined together to form phrases and sentences. So semantics, I mean, if you tell me to take a class on semantics only, I can give a lecture on semantics on the inter class. I mean inter course. Okay, it's very important, very kind of in-depth topic. But very high level, semantics essentially can be classified, or semantics of a sentence can be done in three ways. The first one is decomposition, right? Decompositional semantics. The second one is ontological semantics, and the third one is distributional semantics. Okay, let's look at decompositional semantics. So in decompositional semantics, so what we do, we decompose a sequence into words, and then we essentially try to decompose every word. Okay, something like this. So here you see there are in this particular figure, there's a boy, there's a girl, there's a man, and there's a woman, right? So we look at each and individual entity here separately, and let's assume that these are the three features based on which we characterize each character or each entity, right? Human, female, adult. These are the three features based on which we characterize these four entities. So boy is a human, not a female, not an adult. A girl is a human, is a female, right? Not an adult. Man is a human, not a female, he's an adult, right? And woman is a female, human, and an adult, right? So we look at individual entity, and then we dig deeper into each of the entities and try to understand the semantics. Ontological semantics. So ontology, some of you know what is an ontology, right? Can you give me an example of an ontology? In ontology, essentially tokens or entities are connected through different relations. Give me an example of an ontology. Ontology example. WordNet, right? So WordNet is an ontology. In WordNet, so WordNet is a resource or is a thesaurus, right? Developed by developed through a consortium long back, 1995, 1996. That time, I think it was a 6-7 years of long project. Different versions of WordNet were came up after that. So WordNet in WordNet, what happens is that within a WordNet we have different tokens, right? Let's say motor vehicle, tractor, right, wagon, vehicle, and so on and so forth, golf cart, and so on and so forth, right? These are different entities. Entities are connected through different relations, right? This is same as ER diagram, right? Database entity relationship diagram, right? Here also there are different relations between entities. Is a, right, has part of, right, and then let's say same as, opposite to. These are different relations, right? And these relations can be classified into these forms: synonym, antonym, hypernym, hyponym, meronym, holonym, and so on and so forth, right? These are different types of relations, and through these relations entities are connected, right? For example, self-propelled vehicle is a wheeled vehicle, right? Motor vehicle is a self-propelled vehicle, tractor is a self-propelled vehicle, and so on and so forth, right? Car has part of car window, and so on. So in ontological semantics, then what we do, given a sentence, we look at the existence of individual tokens within the WordNet, for example, within the ontology, and then we return nearest neighbors of that token, right? So for each individual token, we have a set of neighbors which essentially characterize that token, right? And then we look at the similarity between tokens in terms of the neighbors. If there are if there is high overlapping between neighbors, then maybe two tokens are similar, okay? But here the problem is that designing such an ontology is very tough. It requires a lot of manual labor, and the way new words are coming in into the picture, right? It's not possible to come up with a complete ontology, right, where all possible entities, all possible words, tokens are present, okay? Therefore, we essentially came up with this idea of distributional semantics, okay? So this is the premise behind all recent models. For example, all recent word embedding methods like word to vec, glove, we'll discuss in the next week maybe, right? This is the premise behind this. So in distributional semantics, the idea is that a word is represented, or the word is characterized by the surrounding words, right? The meanings of words can be derived from their distributional properties in large corpora of text, right? It relies on the context in which words appear. Let's look at an example, okay? Let's see, you have words like this: dog, cat, lion, light, bark, and so on, right? And you have a document, right? Or you have a corpus. From the corpus, you build this matrix, and this matrix is called co-occurrence matrix, right? So rows are unique tokens, types, right? Columns are unique tokens, right? It's a square matrix. Let's assume it's a square matrix, right? And of course, this example is not a square matrix, but ideally it's a square matrix, okay? And each entity within this matrix indicates number of times the word dog. Let's say this entity 5 indicates the number of times the word dog and the word walk co-appear together, right? What do I mean by co-appear together, co-appearing together? How do we measure this? We have a document, and let's say you have a threshold, you have a sliding window of size 10, right? So you look at 10 words at a time. So you look at first 10 words and see whether they co-appear, which words co-appear together. Then you move it by one step, and then you look at again which words co-appear together, and so on and so forth, right? You determine the sliding window size, and based on that you basically create this matrix. Now if you look at this matrix carefully, dog and cat, right? They co-appear with the word pet, right? They co-appear with the word owner, right? They co-appear with the word run, right? But they do not co-appear with the word bark, right? But still, out of 6 words, maybe in 3 to 4 words they co-appear together. That means they are semantically similar. But if you look at dog and car, for example, right, they rarely co-appear except this owner, right? So simple way of looking at semantics in distributional semantics context is that each row, right, acts as a vector for the token, right? Now if you want to measure the similarity between two tokens, you essentially fetch 2 rows and you measure the similarity between two vectors using cosine similarity, dot product, and other types of similarity measures. Okay, this is a very simple way. There are problems, we'll discuss distributional semantics and the problems in the word embedding chapter. Pragmatics deals with the context. Okay, so very nice definition of pragmatics is that pragmatics is essentially the negotiation of meaning between speaker and listener. So very nice phrase. I like this phrase a lot. This is taken from this paper. The negotiation of meaning between speaker and listener. I already gave an example, right? Do you know what time is it? Right. The literal meaning is essentially, are you aware of the current time? And the answer should be the current time. Whereas the pragmatic meaning is that you are essentially late. Okay. Similarly, if you look at this sentence, can you pass the water bottle? Right. What would be the response? What would be the response? You just pass it, right? But if you say that yes, I can, then stop. Right? then it's not a right answer. Now, discourse is a toughest, is the most difficult part of NLP. It essentially deals with dialogue. Okay, so let's say there's a sentence like this: a mother to John, go to school, it is open today, are you planning to bunk? Father will be very angry, right? There's a dialogue between two parties, and then you ask questions like what is open, bunk what, why the father is angry, and so on and so forth. So you need to look at the entire discourse context and then you respond, right? So the way we ask questions to ChatGPT, we have seen, right? ChatGPT has multiple sessions, right? So let's say within a session, if you ask about NLP and suddenly you move to some political prompts, right, you see the model fails terribly, right? So yesterday I was playing with ChatGPT and I was what's the forget I was asking about an appropriate definition of NLP, right? But in a different context again. The earlier context was different. I was discussing on some quantum theory, etc. And then suddenly I asked, what is NLP? Then it returned that NLP is a neural language processing. Okay. By the way, if you search the word NLP on the internet, right, you see how many full phrases are there for this acronym NLP? 13 to 14. Search with the word NLP, okay, and see how many full versions of NLP are available on the internet. There are 13-14 different versions of NLP. That's very crazy. Okay, so let's look at very quickly. This is the last part of today's class. Let's look at some of the tasks that we are interested in, right? And these tasks are generally used to evaluate the models, right? LLMs and other types of models. Semantic role leveling. So semantic role leveling deals with this, right? So let's say you have a sentence, right, and you try to understand different roles of words, right? In this case, say let's say John drove Mary from Delhi to Pune in his car. So the roles are agent, patient, source, destination, right? Now these roles are already given to you, and your task would be to assign these roles to the words. Okay, this is called semantic role leveling. The next one is textual entailment. Entailment task, right? You are given two sentences, for example. Let's say Ram hit Shyam with a hockey stick yesterday. Shyam got hurt. Okay, so whether the second sentence is entailed from the first sentence or not, right? So in this case, the first sentence entails second sentence, right? Therefore, it's a positive entailment example. Whereas the second one, Ram hit Shyam with a hockey stick yesterday. Shyam did not get hurt. It's a negative entailment. The last one, Shyam got his first goal. So it has nothing to do with the it has nothing to do with the first sentence. So this is non-entailment. Okay. Co-reference resolution. It is actually very tough when the context becomes larger and larger. Let's say this one. John shows Bob his Toyota yesterday, right? Look at this sentence. John shows Bob his Toyota yesterday. It's similar to the one I bought 5 years ago. That was really nice, but he likes this one even better. Now here, is refers to whom? John or Bob? This is not clear. Okay. So in co-reference resolution, we essentially resolve this problem. Right. So there are referring expressions like his, its, these, right, which it refers to, right, is ambiguous, and we essentially try to disambiguate it. It, whether it is referring to Toyota or what, right? That was really nice. Now look at this. That was here. That refers to Toyota, or that refers to the one which I bought 5 years ago. Okay, it's not very clear. He refers to whom? John or Bob? Again, it's not very clear. Okay, so in co-reference resolution, we resolve these problems. Information extraction, we all know, right? Let's say you got an email, and you may have seen Google these days automatically block your calendar based on the email, right? Let's say you booked a hotel, right? You got a confirmation of your booking, and you see that your calendar will be booked automatically by Gmail. And this is information extraction. Information extraction also deals with identifying names, named entities, right? Relations between entities, right? So named entity recognition is again another task, right? There are multiple types of named entity tags: person, location, organization, time, dollar, currency, right? And so on and so forth. There are multiple named entity tags, and the task is essentially to identify named entities. Relation extraction, let's say given two entities, your task could be to extract relations. So these relations are either given, or you can your task can be to curate relations from the web, right? WSD is again very difficult task. What sense disambiguation? Let's say, for example, the word bank, whether bank refers to a financial sector or banks is a river bank, is something that we need to disambiguate. Again, Apple, and so on. Sentiment analysis, all of you know, right? Essentially, the task is to categorize every sentence into positive sentiment, negative sentiments, or neutral sentiment. Another related task is emotion detection, right? There are 6 different emotion tags: happy, sad, etc., and you categorize every utterance into emotions. Machine translation is very important task. It's one of the oldest tasks in NLP, right? I mean, in this class, I wanted to also talk about the history of NLP, but I thought let's skip it. If you go to Wikipedia and the history of NLP, you see that machine translation is a task we started early 1965. Okay, and in 1965, that time, I think English to Russian, Russian to English, task was there, and there were 65-70 odd sentences, and based on some rules they were able to successfully translate Russian to English and English to Russian, and they thought that it was solved, right? But till date this is an open problem, machine translation. Okay. When you talk about machine translation, there are bias within the model. Okay. For example, if you translate "she is a doctor" with Google Translator, you see this kind of translation, "वो एक doctor है," right? English to Hindi. Now you use the same Hindi to again translate it to English. You see, then the Google Translator will say that he is a doctor, right? Because of course, I think that today's Google Translator has been updated, but it has been taken long time before. But anyways, so there is bias. But now look at this one. Okay. First पे खाना सख्त मना है. And this is a translation. Eating carpet strictly prohibited. Okay. Okay. So the next task is summarization, text summarization, where given a long paragraph or a document, your task is to summarize it into short paragraph, right? Even very short kind of TLDR summary, one-line summary, right? There are three different types of summarizations. One is extractive summarization, where you identify important sentences from the document and you just copy paste those sentences, right? And you form the summary. Whereas abstractive summarization, you identify important sentences as well as the semantics, and you rephrase them, right, to generate the summary. The third type is aspect-based summary, where given an aspect, okay, your task would be to only summarize document with respect to that aspect, right? Let's say you have a set of reviews of a product, right? You are only interested in getting a summary of the reviews with respect to, let's say, battery charge, right, of a mobile, right? So the summary should be aspect based. And of course there are other types of summaries like extreme summarization, like TLDR, multimodal summarization, and so on. Question answering, again an unsolved task, right? Earlier people had been thinking that this may be solved, but it's not a very easy problem. There are three types of questions that we are interested in: factoid questions, right? Like who is the president, right? Who is the father, who is the mother, and so on and so forth, right? List type questions: what are the islands in India, right? You basically produce a list, and a descriptive question, which is the difficult one. Factored questions and list questions are easy to evaluate, but descriptive questions are difficult to evaluate. Dialog systems, you all know, right? Chatbot is an example of dialog systems. Okay, so we will see how these tasks can be solved using large language model. Okay, thank you.